This is for Year 12 specialists, an introduction to 6G, rational functions and how you might graph them. A rational function is a function which has one function divided by another. So here are two examples of rational functions. I've got this cubic divided by this quadratic. I've got this linear divided by this linear. So that's what we consider to be a rational function. What I can do is I can use algebra to change its form from this into this, or I can use algebra or a mixture of polynomial division that goes from here to here. How does that happen? So to this fraction here, I can write the numerator separately over the denominator. So I can break my fraction into two separate fractions. Then of course x divided by x gives me 1. And some algebra for this second one, I could separate my numerator into x cubed plus 2x and over x squared plus 2 minus 1 over x squared plus 2. There's a common factor in the numerator of x that can come out, and then this cancels with this to leave you with x. Now you needed to be hinted towards that particular expansion, otherwise you could perform a polynomial division, and x squared plus 2 goes into that x times with a remainder of -1. Therefore, we end up with x minus 1 on top of x squared plus 2. So I can use algebra or polynomial division to put it into the form that I would prefer. Okay, what can I do with this? To find the x-intercepts, I would set y equal to 0 and solve. To find the y-intercept, let x equal to 0. To find stationary points, take the derivative and set it equal to 0 and solve. And to find the asymptotes, I'm looking for 1 over 0. So in this particular case, I'll have an asymptote where this is equal to 0. Where this is equal to 0. So I'm looking at the denominators. And if I make x approach infinity and negative infinity, that will give me my second asymptote. What do I mean by that? So as x approaches infinity, that becomes really big, which means my denominator becomes really big. So 1 over a big number is approaching 0. But I'm going to approach y equals x from underneath because I'm going to be minusing this amount. As x goes to negative infinity squared is also big. So we're going to approach y equals x, but also on the underside. In this example, when x goes to infinity, this is my asymptote, x. Y equals x is my asymptote. In this case, as x goes to infinity, that becomes really big, so therefore 1 over infinity is small, so it's going to approach y equals 1, but it's going to be above, because I've got 1 plus something. And as x goes to negative infinity, y is going to approach 1, but it's going to be below, because I'm going to have 1 over a negative very big number.